Good afternoon. Who's awake? Okay, this is at least a live ping check, so we have some people listening. Sometimes I have to go to the follow-up question, like, who's a human being? So I'm going to talk today about Moby and how he is killing your DevOps efforts. I'm not going to talk about this guy. My name is Kris. About 8-9 years ago, I had the crazy idea to organize a conference with Patrick Dubois. We got the name ID from Jim Alspot's talk, 10 deploys a day, devs and ops working together. We got the idea from basically figuring out that there was a lack of conferences where we ourselves felt happy, where we were talking about doing stuff like continuous delivery, large-scale infrastructure, agile, cloud, open source stuff. And for some reason, a lot of people figured out that that really was a conference that was needed to be organized. And well, here we are, again. My day job, I'm the chief travel, trolling, and whatever you can fill in the T for officer at Inuits. We're pretty much like Pragma, open source consultancy shop, about 80 people across mostly the Netherlands, Belgium, and the Czech Republic. Some people figure out that everything really is a DNS problem. When they do, they rant at me on Twitter. And next to evangelizing DevOps, I actually organize a bunch of other conferences. I'm still one of the core global members for DevOps Day, so I coach new startups. But a bunch of other events I'm running is actually a config management camp. We're going to run again in Ghent for the 5th year. And that is a conference where DevOps Days focuses on culture and more best practices and use case stories. Config management camp actually goes deep into the depths of infrastructure as code and everything around it. So if you're into that, please join us in Ghent in February. So what are we going to talk about today? My goal mainly with this talk is to open a bunch of people's eyes. And while doing that, I'm actually going to be reusing a bunch of 8-year-old slides to prove that simply nothing has changed over the past decade. You're laughing, but it's actually scary because it's true. So what is this DevOps thing about? We've seen this over and over. A good summary of DevOps is what Damon Edwards and John Willis figured out after they were interviewing a bunch of people in their DevOps Cafe podcast series. And they figured out it's about culture, it's about automation, it's about measurement monitoring, it's about sharing, and I hope a lot of people also use the S for security. And because SCAM is an anagram of CAMS, we often add the L, so it's lean, which also is an influence. But fundamentally looking back, this is an 8-year-old slide, is basically a global movement that we kind of started to improve the quality of software delivery, leveraging open source experience, which we started in Ghent in 2009. And this actually is a slide which I used at DevOps together with Patrick in Antwerp, which is a huge Java conference. And we started doing that. We started talking about that topic because, well, this is what the old days looked like. You work in an ops department at some company. In my case, back then, it was a large mobile operator in Belgium. And Friday afternoon, close to 5, there's some person who walks into the office with, so here's a tarball. Can you put this in production now? Because we have a live radio campaign, and we need to have this content live. And we go like, we don't have a web server to put that on. We don't have servers. You need a database. Do we need users? It needs to scale because you're going live on television. Okay, let me try this. Give me the tarball. Where is it? I cannot access it. Okay, now I can read it. What is this mess? How am I even supposed to deploy this? Does this sound familiar for you? Has it occurred recently? Yes. Yeah. So then this is familiar too. That's 10 days. Well, you can do it in binary now, so that's 2 days into operation. And we started a global movement where we started talking about we need to do continuous integration. We need to do infrastructure as code. We need to do monitoring. We need to do metrics. And a lot of people got it. A lot of people started working together with their developers, figuring out how to deliver quality software. But a bunch of people were like, we need a tool to do that. So what tool did they choose? What was the ultimate DevOps tool? Oh, come on, nobody? Excel. Yeah. Docker. I remember when Docker first came along, it was like, is this like vagrant LXC with an idle CLI? I mean, we've been using containers for about a decade. It was a bit archaic. It was a bit like you needed to know what you were doing, but as a bunch of Linux engineers, you pretty much knew what you were doing. Oh yeah, these days we call them DevOps engineers. But there was nothing new. We were provisioning virtual machines already for our developers. They could spin them up, destroy them. It worked. Who's been using Vagrant before? A lot of you. But Docker was the ultimate DevOps tool because it gave much more power to developers. And it was easy. It was a really good tool. It is a really good tool. It actually gives a nice abstraction layer around containers. And suddenly we see this huge growth. Like DockerCon is sold out in minutes, and people go there and learn about the thing. It was the new cool thing to do. Michael Ducci started doing this. He started actually doing Ignites with slides only having the words Docker in there. Docker, Docker, Docker. He needs to change his slides now because they're rebranded. The joke is that about a year ago, I was talking to people and say, look, in 6 to 9 months, we're not going to talk about Docker anymore. We're just going to talk about containers, and the name is going to disappear. And then they pulled the trick on me. They rebranded. Didn't really do a good job there because who's read the book? What is the whale about? This is actually what's happening with Docker. It's driving people crazy because it's not really solving the problem. And some people think that I'm the person who's actually driving the other people crazy by saying, hey, maybe we should think about how we adopt this technology. So let's take a step back and let's look at the struggles we had delivering and deploying software. So I'm going to go really far back. Who knows Open Mosaics? One person in the audience. Yes, we managed to make some impact back in the early 2000s. So I actually was a release manager for Open Mosaics, which was a Linux kernel patch which did distributed computing. So you spun up a process, and it was basically load balanced all over your cluster, and you had some limitations, and it kind of worked. It was really good for long-lived calculations. And stuff we started to put in there was, well, if I'm having a process that runs all over my infrastructure, I need to have access to the data. So we put in place a file system, the Open Mosaics file system. And it gave access to all applications to identical data. And it was unstable like hell. And one of my biggest kernel contributions was actually removing that from the code. And we had other problems, like shared memory. And there was a huge limitation on what kind of applications we could use. And some people tried, and some people failed. And what we learned from that experience is that a lot of the applications, in order to work in a distributed environment, we needed to patch them. We needed to work with the developers and make sure that they were aware of the environment they were running in, so that they could actually benefit from everything that was around them. We never managed to make it to the 6 part because there were other stuff going on. We figured out that a lot of things were pretty much solvable by using stuff like Linux HA. The whole ecosystem, Heartbeat, Pacemaker, where you kind of define a resource. This is my web application server, and I want to have like 3 or 5 of these, and they need to have access to this kind of storage or this kind of memory, and that stack juggled them around, and you just said, hey, these 3 resources need to run together. If one fails, services move to the other side. Does that sound familiar to you folks? We're doing similar things now? It's kind of like what most container orchestration things are doing, except we were doing it with binaries and other stuff. And there also, we had some learning experiences. Because the typical application in an enterprise was basically writing a lot of things to disk. And when it failed over to another node, it couldn't access that. So we needed to talk to developers about state. Where do you keep state? Where do you share it? How do you work with that? How do you access your data? Do you put it in a distributed file system? Do you put it in an object store? Because those were kind of popping up. And we needed to talk to developers on how do we figure out if your application is still healthy? Is it just listening to a socket, or do I actually get a business application like I can ask the application, is 1 and 1 2, and if you return 3, I'm going to degrade you? And we wanted to know on metrics, because the load, should we load balance these things? So once again, we learned that we need to talk and work together with developers in order to have scalable, resilient applications. We need to look into file systems, we need to look into monitoring, we need to work together. We also learned that a lot of these things work much better if you have an open source mindset. Proprietary world kept lagging behind and kept trying to figure out how to do these things. So fast forward to now. Cloud adoption in Europe. Who's running in the public cloud? I see 5 hands. 6 hands. Don't raise 2 hands, Henk. It's not there, and there's some kind of weird reason for that. Some of them are valuable, some of them are not valuable. But for some reason, Europe is not adopting the public cloud at the same rate as the Americans are. There could be other reasons for that. They've made other worse choices. So people figure out, hey, we're going to do a private cloud thing, and we're going to get this flexibility of being able to provision and spin up machines and scale out and do that on-prem. And they build the whole private cloud infrastructure. They build OpenStack, they build OpenNebula, whatever. And they put in a Word document in front to get virtual machines. It's not funny, it's reality. I mean, who still needs to fill in a bunch of forms in order to get a VM? I know a lot of people who do. I see a lot of hands shyly being raised. So a lot of those failed private cloud projects basically are identical copies of old physical machines moved. There is no config management in place. There is no monitoring in place. There is no resilience in place. It's pretty much like the traditional IT departments have not learned. They've put their infrastructure behind a cage, and there's still an irrelevant workload. A workflow in front of it that doesn't work. And that brings us to today. Why are a lot of developers using Docker? Because they're fed up with having to talk to their IT department and saying, I want a new VM, I want another new VM, I want another new VM. So what I figured out is we're going to get the biggest and the fattest machine we can get. We're going to get 3 of them, and we're going to run Docker in it and spin up containers and treat them like a virtual machine. And so this is how an enterprise container looks like today. The sad story is I run into a bunch of these. It's a full VM, there's SSH running in there, there's often old school databases running in there, people have backup agents in there. It's horrible. But hey, they're the cool kids, right? They're running Docker. This is enterprise adoption of Docker. And I would be lying if I said that I had only seen this once. And that really saddens me. Because it starts to become the standard. People figure out slowly that doing DevOps adoption means that they need to change a lot. They need to change their software architecture. They need to change the way they deliver software. And still we see this kind of tweets. They took the monolith and they put it in a container. We're doing microservices now, right? You've probably also seen the microservice comparison where there's like one big pile, and now you get a lot of small little brown piles. But fundamentally, those people have not changed a single thing. So software delivery is hard. And while we were doing continuous delivery, we started to realize, well, we need some artifacts, some immutable artifacts that we can get through a pipeline so we can know that what we test at some point, at some stage, it's going to be the thing that's going to end up in production. So we talk about packaging software. We talk about how do we ship software. So how many languages have figured out how to do software packaging? None. Ruby has bundler, has a bunch of things to figure out how to do packaging. Node.js has a bunch of them. Python has a bunch of them. There's a bunch of trends like this on the internet. What is pip, Python package manager? How do you install it? Well, you use another package manager to actually get the package. And how do you get that package manager there? So we got layers and layers and layers. For those who were at the meetup yesterday, I actually documented how we went from building a Ruby stack, isolated, secure, so that we had a package which we could deploy. Something unique, identifiable. And we figured out, well, all of this dependency management, people now just put it in a Docker container and here it is. 8 years ago, we just said, here's VM. It's a coffin, it's dead. Because what happens when we start shipping around VMs, thank God VMware fixed that for us, is we get image sprawl. Somebody builds VM, modifies something in there, gives it to the next person. He modifies something in there, gives it back to the other one. She starts modifying stuff. And before you know, we got 15 different variants of a VM sprawling around. And none of them is in sync. And when you need to do a security update, everything breaks. What did we do to solve that problem? We started doing infrastructure as code. So everything that was deployed was programmatically described inside of our stack, and we could actually modify it, and we knew that all of our systems were in sync because we described how it was looked. So that brings me to August last year. I was actually giving pretty much a similar talk at the keynote at Mosaics in Amsterdam. And I came back at a customer. Actually, it was a Friday, because Mosaics was Wednesday, Thursday for me. And I was sitting with the ops department, talking about new technologies, talking about improving their Puppet stacks, talking about improving their Jenkins stacks. And there's this person who walks in and says, here's a Docker container. Can you put this in production? I'm like, they got to be trolling me here. They weren't. It was dead real. Some manager had commissioned an external company to build an application. He didn't give them any specs, he didn't talk to operations, they had no clue where it's going to be deployed, and they came with a Docker container. Actually, they didn't come with one, they came with 3. All with different sources. From Alpine, from Ubuntu, from whatever. And, well, I think the Alpine one actually was the Mongo one, which was not the standard database within that organization. And we started talking about it. It's like, so give me the container, let's import it. It doesn't work. Okay, give me the Docker file. Let's try to build this. It didn't build. Because it worked on the developer's machine, but was not behind a corporate proxy. It did not work on the Jenkins infrastructure of the customer, where it was behind a corporate proxy. It couldn't reach all the artifacts it needed for deployment. So they set up an external repository, started pulling in the external packages, and we started adding complexity to a stack where we needed to have it deployed in the evening. We pretty much knew we were not going to succeed with that. My suggestion was like, so I got a fully puppetized cube stack here with everything prepared. Can I please spin this up? Oh no, we don't have resources for that. We only have one machine for that stack. And the security came along, like, we're not going to put these things in production because we've never used them. Rightfully so. And backups, because there was user data going to be entered. And storage and high availability. And suddenly it was like, oh, this is time travel. We've solved these problems. We've seen this before. Only now the artifacts got bigger, and if you get such a container in your face, it's really gonna hurt. So this happened. And it wasn't fun, because we were like, we've had this discussion. For the past 5-6 years, we've been talking to people like, we need to collaborate, we need to know where we can deliver stuff, we need to figure out metrics, and then people just show up like, here's a container, put it in production. And we come back with these questions, like, how do we build them? Is this even secure? Can we rebuild it? Do we even need a container for this? How do you manage the hosts on which you run the containers? Locally, in your own data center, with storage. Oh, that means you need OpenStack with storage backends, you need Cinder, and on top of that you have Cube. And wait again, you're running Hello World, right? That's your goal. And we also figured out, while we were going through those experiments of learning how Docker really worked, that it's not really the shiny open source project I'm used to. I mean, 20 years ago, we went to Linux because it was rock stable, because it actually worked. And these days we have Igor tweeting out, so how do you fix the running application in Docker? Oh, you restart it. How do you fix a full Docker host? You reboot it. That's not the kind of operations I'm used to. Others might, but I'm not. I ran away from that about 15 years ago. I don't want to get back there. So what we have now in a lot of environments is this. We've got a sinking whale. We got an image which is built by a developer who basically already reffed, because he's a contractor for only 6 months, and the image is managed by nobody. So we're back at the same problem we were. Who dares to upgrade that application? Nobody, because we don't know how to. We don't have a pipeline. It's something built by somebody. Can we rebuild this with these dependencies? Typically not. Typically this is what the developers don't care about. And we realized that going to production is like Michael Ducci compared. Docker on a local machine is one thing, running it in production is another thing. So how do we solve this? I mean, we need to figure this out. A developer has one local machine. He has typically one local application. It could be multiple containers, but once we go to running this in production, we want to have high availability. We need to have a cluster. We need to have things like Swarm, Cube, Mesos. And it's not going to be that one application, I hope, because if you spin all of this up for one application, it's going to be kind of expensive. So your stack is going to have multiple applications. We need to deal with that. We need to talk to the developers and make them realize that it's not on their machine alone. There's going to be the network part. If your developer is locally running Docker, he's going to connect to your application, local host port 80, whatever. That's not going to work in production, because in production I need to have security. I want to have that connection encrypted. I need to have a way where I name an application and my application goes there. So I need to figure out ingress, load balancing, service discovery, or just go to some vendor and get logged in there. But it's completely different from somebody on his local machine running a container. And we need to have that conversation. We need to solve that problem. So storage. Which of your developers has its full data stack? Mostly none. They have a local disk. They have no real data. But in production, we need to take care about real, actual customer data. We need to think about shared storage. Actually, we want the developers, just like 5 years ago, to use object storage. But for some reason, 2017 is again the year of NFS, because we still have not figured out distributed storage in a containerized world. It's evolving, but it's not there. So what about building these things? Well, the developer starts on a local box with a Docker file, and it works for him. But we need to have a pipeline in place, just like with all the other applications, where we do security, where we have an image registry, where we actually publish the artifacts, and so on. We go from, it works on my machine, Docker pull, you only live once, to, figuring out when it breaks. We need to add monitoring, metrics, security, all over again. We had these discussions, we had these talks, but because there's a new pattern, there's a new tool, apparently people don't need to do that anymore. And that's painful. You see, the difference between running Docker locally and running it in production, there's a huge gap to bridge. A lot of these things are not at the maturity level we want them to be. Docker itself is not at the maturity level we want it to be. I mean, this morning I was actually debugging yet another XFS problem. From metrics, we start to get a standard around Prometheus. We start to get a bunch of people who are adopting it, but it's still not where an enterprise wants it to have. So fundamentally, what has changed over the past 8 years? Not much. The name of the artifact changed. But we still need to work on that DevOps part. We still need to work on that culture part where people do collaborate, where people actually realize that putting software in production is not the same as having it run on their machine. And I mean, I love Docker as a technology because I like to spin up stuff fast and I like to play with it. But I really hate what it has done to us on a culture level. Because for some people, it really has set them back. It really has been blocking delivery. And I know I took Docker as an easy victim. John Topper last week at DevOps Days London actually did a similar talk, and he chose MongoDB as the same victim. Because DevOps is not about tooling. DevOps really is about people working together and understanding what the other persons in the room are doing. It is mostly still about culture. And tooling can help you there, but even more so, it will actually kill all your DevOps efforts.